All right, so we're going to look at what's a piecewise function. A piecewise function is a function that is defined by two or more equations over a specified domain. Okay, so they're going to give us some information about an equation, but with that information, they want us to highlight a certain part of that equation. So I want to show you for our next example. It says evaluate the piecewise function at the given values of the independent variable. We have two equations, 4x plus 4, or f of x is equal to 4x plus 4, and we have f of x is equal to 4x plus 7. But if you notice, there's some stipulations for our first equation. We can say y is equal to 4x plus 4. Okay, it says if x is less than 0. So let's go back to what we know about graphing a linear equation. And then we'll go and do the rest of this. But just hold off for a second. I want to just talk about how do you show you how to graph a piecewise function. So y is equal to 4x plus 4. Our slope is 4. We're going to rise 4. We're going to run 1. Our y-intercept is at 0, 4. So here is 0, 4. We're going to go up 4 units, 1, 2, 3, 4, and over 1. If you want to go up again, 1, 2, 3, 4, and over 1, we can do that. If you want to go down, we want to go the opposite. Instead of going up and then to the right, we can go down 1, 2, 3, 4, and 1 unit to the left. We can do that as well. Now, I'm going to connect. Okay, let's make this a little bit better here. Okay, now our stipulation says we have our first equation. It says we only want to look at values when x is less than 0. So here is 0. That's our independent variable. We only want to look at values when x is less than 0. So here at 0, 4, because it says less than 0, we have an open circle. That means we want to look at all values that's to the left of 0, meaning -1, -2, -3, -4. We can keep going. Any values to the right of 0 must be excluded. That's not part of this first equation. Okay? So here's our f of x equals to 4x plus 4. Okay, or we can say y. Um, but since we have a function, okay, we'll keep it as f of x. Now, so that's our first equation. Our second equation, yes, we have the function f of x equals to 4x plus 7. We just look at the linear function. Our slope here is 4. So we're going to rise 4, run 1. And our y-intercept is at 0, 7. And the reason why I'm using a pencil because I know that there's going to be a certain part that we have to erase, and using the pen would not suffice here. Now it says if x is greater than or equal to 0. So let's go ahead and graph this first part. We start at 0, 7. And we're going to go up 4 units. 1, 2, 3, 4, and over 1. Okay. Now, if you want to go down 4 units and to the left, you can. But here's my line that I'm going to draw here. Now I could draw it all the way out, but I want to talk about our stipulation. When x is greater than or equal to 0. So we look along the x-axis. What this is saying for this second equation, any values that's greater than 0 and or equal to 0, we want to represent. That means any value that's to the right of 0 along the x-axis. Anything to the left, we want to omit. So we're just taking away a piece of that graph. And because it's greater than or equal to 0, we're going to have a closed circle. Less than or greater than, when there's no equal sign there, is going to be an open circle. So our closed circle. So here we have f of x is equal to 4x plus 7. Okay, so now I'm showing you how to graph. Even though this question is not asking us to graph it, I want you to see how to graph this. Okay. Now, let's answer the question. There are two ways that we can answer the question. We can answer the question with the graph and we can answer without the graph. It says here for our first example, it says find f of negative 3. Remember, this is our independent variable, or this is our input. This is our x value. However you want to, let's write this out. Independent variable, our x value, our domain. So it says here, find f of negative 3. Now, if you want to, you can look at the graph and count over negative 3 and then count down, and we can go that route. Okay. Or which function, our functional, our equation here, where would this f of negative 3 fit? Will it fit when x is less than 0? Or will it fit when x is greater than or equal to 0? We're going to use the first equation when x is less than 0, because x here is negative 3. So we want to find f of negative 3. We can work it out this way. So we have 4 times negative 3 plus 4. We have negative 12 plus 4. That gives us negative 8. Okay. Therefore, f of negative 3 is equal to negative 8. B, we want to find f of 0. Okay. Now look at our stipulation. Then it'll determine which equation we're going to be using here. Do we want to look at when x is less than 0? Yes or no? All right, so f of 0, x is greater than or equal to 0. We want to use this second equation because x can be greater than 0, x can be equal to 0. So let's go ahead and substitute those values into the second equation. For x, 4 times 0 plus 7. We have 0 plus 7, therefore it's 7. Our independent value is 0, and our dependent is negative, I put negative 8, is 7. Here we go. Okay, so you can even check. At 0, here is your 7. And then we have C, f of 1. At 1, look at your graph. At 1, we see a point that's 11. Okay, or we can go and determine which equation will we use, but it determines by the restriction here. So we're going to use that second equation again, and we're going to plug 1 in for x. And we have 4 plus 7, which gives us 11. Therefore, f of 1 equals to 11. There you go. Okay, so let's look at this last example. It says the domain of the piecewise function is negative infinity to positive infinity. Graph the function and then use your graph to determine the function's range. Okay, so our first function, we have f of x is equal to x plus 1, where the slope is 1. The y-intercept is at 0, 1. So let's go ahead and graph this. We start at 0, 1, go up 1, over 1, rise and run, up and over. So it says, here's our restriction, if x is less than negative 4. So that means I need to find any value that is to the left of negative 4. So what I need to do is, let's go find some points in the opposite direction for this equation. We're going to go down 1 and to the left, down 1 to the left. Okay, so when I connect, just want you to see what the line looks like. But it says at negative 4, we're looking at all values to the left. So at negative 4, we have an open circle because that means negative 4 is not included. But then anything to the right of negative 4, we're going to erase. Okay. So just make sure I get this exact. There we go. So here's the line. Okay. So this is f of x equals to x plus 1. Then the second function, you have f of x is equal to x minus 1. Our slope is negative 1. Our slope is 1 over 1. We're going to rise 1, run 1. And then our y-intercept is at 0, negative 1. So we're going to start at 0, negative 1. Go up, over. And then let's do some downward. Go in the opposite direction. Go down and to the left. Okay. All right. So let's finish this out here. It says, our stipulation says if x is greater than or equal to negative 4. Okay, so at negative 4, we have a closed circle because that means negative 4 is being included, but we're looking at all values that are to the right of negative 4. So anything below negative 4, let's erase. Anything to the right above negative 4 there, we're going to connect. There we go. And this is our line. Now, if you notice, that really there's nothing that's separating at -4 because we're including -4. So it's saying what would be its range. Okay. If the domain is -infinity to +infinity, the range is going to be the same, -infinity to +infinity for the value of y. Because there's really no it doesn't stop, it continues, because this -4, we have that greater than or equal to -4, meaning -4 is included. So we are finished.